Hi guys, welcome back to another video. So I just came back from buying milk and now here I am. Sorry about the delays. Okay, so today we have, as usual, an MIT integration B question. This was in 2024, qualifier question number 18. So we have the integral of the sum of x to the power of 2 to the power of n minus 1012, where n goes from 0 to 2024. If you would like to try this, you can pause the video right now. Okay, so the first step to solve this integral here is to rewrite, to expand the integrand. So we're going to rewrite this. Oops, 1, 0. So we're just going to substitute n equals 0, n equals 1, n equals 2, all the way to n equals 2024 to this expression. So here we have, if n is equal to 0, you have x to the power of 2 to the power of 0 minus uh 0 to the 0 minus 1012. So that means this is x to the power of 2 to the power of minus 1012, right? And then x to the power of 2 minus x to the power of 2 to the power of minus 1011. And you can continue this pattern. And I'm going to give a bit of a I'm going to break this pattern a bit. So I'm going to substitute the phi tool number that is n equals 1012. So we have x to the power of 2 to the power of 0. So this is the term number 1012. And then keep going until you have x to the power of 2 to the power of 1011, and then x to the power of 2 to the power of 1012 dx. So this is actually just a whole bunch of uh, terms of the form x to the power of something, albeit the powers themselves are also powers. But no problem, we can do that too. So we simply have to use the power rule here, actually, even though it might seem a bit complicated. So this is really just a standard integrand of the form x to the power of n, where n here is actually a fraction. So like this is actually x to the power of 1 over 2 to the power of 1012 or something like this. But no problem. So you just have to write 1 over 2 to the negative 1012 plus 1 x to the power of this number. And yeah, by the way, be careful about the levels of the uh exponents. So basically the problem that you're going to face here is just figuring out exactly where the power goes. Okay. So this, and then basically the same thing happens for every other uh term. Well, for the middle term, it is actually quite easy to see here. It's actually 1 half x squared, because this itself is x, right? So the integral of x is 1 half x squared. Then x to the power of 1 over 2 to the power of 11 plus 1 x to the power of 2 to the power of 1011 plus 1 plus 1 over 2 to the power of 1012 plus 1 x to the power of 2 to the power of 1012 plus 1, and there you go. Yeah. So here we're just going to substitute the integration bounds into this result. One thing for sure, when we substitute x equals 0, all the terms evaluate to 0. So you only need to care about what happens when we substitute x equals 1. So actually, when x is equal to 1, this here just evaluates to 1, this evaluates to 1, this evaluates to 1, etc. So what you're going to do here is 1 over this plus 1 over this plus etc. and then 1/2 plus blah, plus 1 over 2 to the power of 1011 plus 1 plus this. Okay, so now let's try to evaluate the sum. The trick here is to take a look at the ends of the summation. So the left end and the right end. So I'm going to put a bit of a scrap work somewhere, maybe here. So notice that you can group the sum by looking at the leftmost term and the rightmost term, and then the second leftmost term and the second rightmost term, etc. And you'll be doing sums of the form 1 over 2 to the power of a, practically minus a plus 1 plus 1 over 2 to the power of a plus 1. So this here is equal to 2a, 2 to the power of a plus 1 plus 2 to the power of minus a plus 1 over 2 to the power of minus a plus 1 times 2 to the power of a plus 1. So the numerator is 2 to the power of a plus 2 to the power of negative a plus 2. The denominator here, notice that this here, this here multiplies to 1. And then 2 to the power of minus a plus 2 to the power of a plus 1. And it actually evaluates to the same thing as a numerator. So that means this is equal to 1. What that means is, let's take a look at how many pairs there are. So this is one pair. And then this is the second pair. And you notice that uh, you have a number of pairs. So here you have 2 to the power negative 112, 2 to the power negative 1011, all the way to here you would have 2 to the power of negative 1 as the power of x. Same goes here. This is going to be x to the power of 2 to the power of 1. So there are 1012 terms to the left and 1012 terms to the right. So actually, you would have 1012 pairs, which evaluate to 1, plus the middle term, which is 1/2. So this evaluates to 2025 over 2. Did you get this answer? Let me know in the comment section below. So that's all that I have for today. See you in the next video.